Let's take a look at the life cycle of the red blood cells. Remember that red blood cells only live about 4 months. The reason they have such a short lifespan is because they don't have a nucleus. And without a nucleus, they don't have any DNA, and so they can't make any new proteins to replace the old worn out proteins. And that's why they die after about 4 months. So we need to continually replace our old worn out red blood cells. And to do that, we undergo a process called erythropoiesis. So that word, erythro, just means red, referring to the red blood cells, and poiesis means to form. So we end up making about 200 billion red blood cells a day, which is pretty crazy to think about. So who's in charge of starting the production of the new red blood cells is actually the kidneys. So that would be good to remember. And the kidneys are going to be sensing the oxygen levels in the blood. And when they sense that the oxygen levels are a little bit low, they're going to secrete a hormone called erythropoietin. And erythropoietin will then travel to the red bone marrow and tell the red bone marrow to start making new red blood cells. So in our red bone marrow, we have these hematopoietic stem cells that, depending on what signal they get, they can differentiate and form into either red blood cells, white blood cells, or platelets. But if they get the signal from erythropoietin, then they'll go ahead and make new red blood cells. And over here on the right, we've got a blood smear. And sometimes when the red bone marrow is working really hard at replacing new red blood cells, like if maybe you've lost a lot of blood, sometimes you'll see these immature red blood cells, and these are called reticulocytes. So they're a little bit larger than the red blood cells, and they're a little bit darker in color, and that's just because they still have some ribosomes in them that haven't been destroyed yet. So sometimes you'll see these reticulocytes listed on the blood work, and they're just immature red blood cells, and it's just a sign that the bone marrow is working hard and it's making new red blood cells. All right, so where the red bone marrow is in adults, it's in the appendicular skeleton and also in the proximal femurs and humeri as well. So that's where these stem cells would be located that would be making our red blood cells. And up on this top picture, you can see that they've done a cross section through the bone, and you can actually see the red bone marrow is actually red. And then in the middle here, we've got the yellow bone marrow, which is actually filled with fat, and the stem cells are not located there, so there's no production of blood cells there in the yellow bone marrow. So here we can see these hematopoietic stem cells, and depending on which signal they get, like if we've got erythropoietin around, then we would go down this pathway and make the red blood cells. But other signals will tell the hematopoietic stem cells to make platelets, or the various types of white blood cells could be made as well. We need a couple things to make more of our red blood cells, and one of them is iron. Iron is really important because remember it's part of the heme group in the hemoglobin, and that's where the iron is going to bind to. It'll bind to the iron atom in the heme group. And where we get the iron from is from our diet. And then we also need some vitamin B12 and folic acid is just another type of B vitamin. And these are needed for DNA replication. So if you don't have enough of these B vitamins, then these hematopoietic stem cells can't divide enough to form enough of the red blood cells. So you end up with anemia from not having enough vitamin B12 and folic acid. And speaking of anemia, anemia is just defined as a decrease in the oxygen carrying capacity of the blood. And it's caused by either there not being enough red blood cells in the blood, And this would mean that the hematocrit would be low, or there would not be enough hemoglobin in each of the red blood cells. And as far as the symptoms that a patient would be experiencing with anemia, they would feel tired all the time. And if they went up the stairs, they might get out of breath really quickly. And they also would look pale as well. There's a lot of different causes of anemia, and we'll just look at a few. You don't need to memorize any of these, but just thinking about them. It could come from dietary problems. If you're not getting enough iron in your diet, you could have an iron deficiency anemia. Or maybe you're not getting enough vitamin B12. You could get what's called pernicious anemia. Pernicious just means a gradual onset of something bad. You could have hemorrhagic anemia. Maybe you've had a lot of blood loss from, an accident or something. And then we have hemolytic anemia. Remember, hemolysis just means that the red blood cells are bursting, and that could be caused maybe like by malaria or sickle cell anemia, which is in the picture on the right. Or maybe your immune system decides that it no longer likes your red blood cells and sees them as foreign and attacks them. And now you have an autoimmune hemolytic anemia. If you're in renal failure, that could actually cause anemia. And the reason that renal failure causes anemia is that if your kidneys are not working well, they won't be secreting as much erythropoietin. And now your red bone marrow won't be getting the signal very often to make as many red blood cells. And so you're not going to be making as many, and that will cause anemia. And then another cause of anemia would be aplastic anemia. A meaning without, and plastic means growth. And this means that your hematopoietic stem cells are no longer working. So maybe they've been killed off by radiation from like chemotherapy, or there's certain drugs that might kill them off. So that's a really bad one to get. So those are just some examples of causes of anemia, and there's a lot more that could cause anemia as well. All right, so with our red blood cells only lasting for about 4 months, when they get old, we need to have a way to get rid of them. So our spleen is the filter in our body. So there are little capillaries inside of our spleen, and in our spleen we've got hanging out there some white blood cells called macrophages that are phagocytic. And the old red blood cells will have trouble bending and fitting through the small capillaries in the spleen. So the macrophages will notice those and eat any of the old red blood cells that are having trouble getting through the capillaries in the spleen, and so they'll just eat them and then they'll be gone. So these macrophages, when they break down the old red blood cells, they will break down all the hemoglobin that is inside those red blood cells. So in the hemoglobin, remember we've got two parts. We've got the protein part, the globin chains. So we'll break those down into amino acids, and then these 4 heme groups, those will also get broken down too. So we're going to pull off the iron and reuse that, and then what's left of the heme group is going to be turned into what's called bilirubin. And the bilirubin will be kind of a yellowish orange color. And then here's just a close-up view of the spleen. And these old red blood cells will go in there, and then the macrophages will eat them and break down the globin, the protein part of the hemoglobin, and the amino acids will just be reused. And then the heme group that was on the hemoglobin will pull off the iron, reuse that to make more hemoglobin. And then what's left of the heme group becomes bilirubin, and then we'll look at what happens to that next. Okay, so from the spleen, the bilirubin will then be released into the blood, and then it's going to go to the liver. And from the liver, it's going to go two places. So it can go into the intestines, or it will go back into the blood, and then finally to the kidneys, and then into the urine. Okay, so that's where the bilirubin is going to be going. So from the liver, the bilirubin can be secreted in the bile into the intestines, where it ends up mixing in with the feces, and it actually turns the stool brown. So that's why our stool is that color. If your gallbladder gets blocked and you're not able to secrete the bile with the bilirubin, your stool will not be brown. It's actually white, which is really weird looking when you see it. And then the rest of the bilirubin that doesn't go out into the intestines gets released from the liver into the blood, and then will be traveling through the kidneys, gets filtered out in the kidneys, and then gets excreted into the urine, where the bilirubin in the urine will make the urine yellow, which is interesting. Okay, if you have bilirubin building up in your blood, you've got too much bilirubin for several reasons, it will actually turn you yellow. So the whites of your eyes will turn yellow, mucous membranes turn yellow, and even your skin will turn yellow, like on this little baby over here. And when you turn yellow, we call that jaundice or icteric. Okay, and we talked about how the iron will recycle and just use that to make more of our hemoglobin. And then we do get some new iron from our diet as well. Okay, so this is a really important picture to know. So I definitely would study this for testing purposes. So this just shows the whole life cycle of these red blood cells. So remember, everything is going to be starting here in the kidneys. Kidneys will sense when the oxygen levels are low, and they'll say, oh, we need some more red blood cells. So they're going to secrete this hormone, erythropoietin, that will travel to the red bone marrow, tell the red bone marrow to make more of the red blood cells. These red blood cells will circulate in the blood for about 4 months. But after 4 months, they're too old, and so as they travel through the spleen, they get stuck there, and the macrophages will take them out. They'll phagocytize them and break down the hemoglobin. And so the globin part, the protein part of the hemoglobin, the amino acids just get reused. The heme group gets broken down and we'll reuse the iron to make more hemoglobin. And then what's left of the heme group after the iron's taken off turns into bilirubin. And then that bilirubin travels to the liver. And the bilirubin will be secreted with the bile into the intestines. And that's what makes the stool brown. And then the rest of the bilirubin goes out into the blood and then gets filtered out by the kidneys into the urine, and that's what makes the urine yellow. So that would be your erythrocyte life cycle. So I definitely would spend some time looking at that and knowing that.